Hey guys, so in today's lecture, we are going to see a new topic, that is brakes. So, what is a brake? So, as we know, that brake is defined as a mechanical device that is used to absorb the energy possessed by a moving system or mechanism by friction. So, it is used to absorb the energy. So, the primary purpose of the brake is to slow down or completely stop the motion of the moving systems, such as rotating drums, machines, or vehicles. So, it is also used to hold the parts of the system in position at rest. So, an automobile brake is used either to reduce the speed of the car, so it is used to reduce the speed of the car, uh, it is used to reduce the speed of the car or to bring it at rest. So it is also used to keep the car stationary on the downhill road. So the energy absorbed by the brake can be either kinetic or potential or both in automobile applications. And the brake absorbs the kinetic energy of the moving vehicles. So in hoist and elevator, the brakes absorb the potential energy released by the object during the braking period, and the energy absorbed by the brake converts it into heat energy, and it is distributed to the surrounding. And heat dissipation is a serious problem in the brake application. The problem is heat dissipation. Now let's classify the brake. So let me classify the brake. So classification of brakes. So brakes are classified into mainly three categories, that is A, mechanical brake, B, hydraulic or pneumatic brake, or C, electrical brake. So uh, brakes are classified in these three categories. So mechanical brakes are operated by means of such as lever, springs, and pedals, and depending upon the shape of the friction material, the mechanical brakes are classified as block brake, band brake, block and band brake, internal shoe expanding brake, while hydraulic and pneumatic brakes, which are operated by fluid pressure such as oil pressure or air pressure. Electrical brakes are operated by magnetic force, and which include magnetic particle brakes, hysteresis brakes, and eddy current brakes. So brake capacity depends upon the very following factors. So let's decide the factors uh, that affects capacity of the brake. The unit pressure between the braking surface. So the unit pressure between the braking surface. So it is pressure, then the contact area. The second is the contact area between the surface. The third is the radius of the brake drum. So the third is the radius of the brake drum. So these are the main three factors. Other factors are also important, that is coefficient of friction, that is mu, between the surfaces, and the ability of the brakes to dissipate heat, that is equivalent to the energy being absorbed. So heat dissipation. So these are main five factors which affect the capacity of the brake. So this is the classification of brakes. Now let's see various energy equations. So energy equations. So the first step in design of a mechanical brake is to determine the braking torque capacity for the given application, and the braking torque depends upon the energy absorbed by the brake. So how much kinetic energy is absorbed by the brake? So when a mechanical system of a mass m moving with velocity v1 is slowed down to the velocity v2 during the period of braking, so the kinetic energy absorbed will be 1 by 2 m v1 square minus v2 square. So when this is the kinetic energy absorbed by the brake. So v1 and v2 are initial and final velocities. Similarly, the kinetic energy of the rotating body will be given by, that is Ke is equal to 1 by 2 I omega 1 square minus omega 2 square. So if I write that is moment of inertia's formula, that is mk square, is m is mass and k is radius of gyration. So it will be 1 half mk square into omega 1 square minus omega 2 square. So omega 1 and omega 2 are initial and final angular velocities of the rotating body. Now next, in certain applications like hoist, brake absorb the potential energy released by the moving weight during the braking period, and that potential energy is nothing but mgh. So when a body of mass m falls from a distance h, the potential energy absorbed by the brake during the braking period is mgh, where g is gravitational acceleration, m is mass, and h is the height. Depending upon the type of application, the total energy absorbed by the brake is determined by adding the respective quantities of the energy discussed in this. So this energy is equated to the work done by the brake. So this energy will be equal to E is equal to work done by the brake, that is TB into theta. So E is the this energy is, that is total energy absorbed by the brake. TB is the braking torque. This is the torque, but it is the braking torque. So braking torque in Newton meter, and theta is equal to the angle through which the brake drum rotates during the braking period. So is the angle through which the brake drum rotates during the braking period. So now let's discuss a brake, that is block or shoe brake. Block or shoe brake. Let's discuss this block or shoe brake. So suppose there is a rotating drum which is rotating. Uh, now there is a brake here attached. So that is a block. This is a block, or you can call it a shoe, and this is attached to a mechanism. There is a lever where you can apply the brake, and this is a pivot. This is a pivot. So when you apply uh, the force in this direction, so this will be apply force in this direction, so it will call pivot. So when force is applied in this direction, that is F, so the brake is applied in this direction. Now due to friction, the friction force will be mu into Rn. So mu is coefficient of friction and Rn is the normal reaction force. So the normal reaction force, so let me give center to this. So the normal reaction force will be in this direction, that is Rn. And suppose the distance between the pivot and the brake is B, and the pivot and the lever is A. Now there is an angle that's been extended on this brake due to this contact, that angle is suppose theta. Now in this drum brake, so a block or shoe, so it consists of a block or shoe which is pressed against this rotating drum. So it is pressed against this rotating drum. The force on the drum is increased using the lever. So this force can be increased during by forcing this lever. If only one block is used for this purpose, aside from the thrust on the bearing of the shaft, the drum will act. This can be prevented by using two black blocks or two sides. So here also you can keep a block. So two blocks also you can use here. So material softer than that of the drum or the rim of the wheel is used to make the blocks so that this can be replaced easily on the bearing. So wood and rubber are used for light and slow vehicles, and cast steel is used for heavy and fast vehicles. Now here let me give some nomenclatures. So let small r be the radius of the drum. So let's small r be the radius of the drum. So this is r, and mu is the coefficient of friction. Then Fr as the radial force applied on the drum, Rn as the normal reaction force, F is the force applied at the lever, and Ff is equal to friction force. Now, now let's assuming the normal reaction force Rn and the friction force act at the midpoint of the block. So the braking torque uh, Bt will be equal to friction force, that is Ff, into radius. So into radius, so it will be mu Rn into r. The direction of the friction force on the drum is to be opposite to that of the rotating, while the block is in the same direction. So here force F into A. So here this force F into A, this force F into A will be equal to this force, reaction force, that is Rn into B. So F into A will be equal to Rn into B plus the uh, friction force, that is mu Rn into C, that is mu Rn into C. So it is mu Rn into C. So this is the distance, this is the C here. So if I resolve this forces, so I get, if I make subjects of Rn, so Rn, if I take common here, so I'm left with here, that is B, sorry, this friction force is in opposite direction, so it will be negative. So if I take Rn as common, so here I left with here, that is F into A is equal to Rn as common, that is B minus mu C. B minus mu C. If I take Rn as a subject, so Rn will be equal to Fa divided by B minus mu C. So uh, if I want to find as F, what is the force? So F will be equal to Rn into B minus mu C divided by A. Now, so if B is equal to mu C, that is B is equal to mu C, the force will be equal to 0, which implies that the force needed to apply the brake is virtually 0, or that once the contact is made between the block and the drum, the brake is applied itself. Such a brake is known as self-locking brake. So at the moment of the force Ff about O and is in the same direction as the applied force F, the Ff aids in the applying brake, and such a brake is known as self-energized brake. So the two terms, it is self-locking brake and the second term is self-energized brake. So what is the difference? So in self-locking, the brake is applied as soon as it touches the block, while in the self-energized brake, the friction force Ff aids in applying the brake, and so this is called self-energized brake. So if the rotation of the drum is reversed, that is made clockwise, uh, which shows that the required force F will be greater than what would be the drum rotates in counterclockwise. So if the rotation of the drum is reversed, that is for self-energized brake, so F will be equal to Rn into B plus mu C. So this friction force is helping, it will be in plus direction and not in negative direction in self-energized brake upon it. So this shows that the required force F will be greater than what it would be when the drum rotates counterclockwise. So the force required will be the greater. So if the pivot lies on the line of action of EF, so the pivot lies on the line of action PF, that is at O dash, so C will be equal to 0 and F will be equal to Rn into A upon B, so which is valid for clockwise as well as counterclockwise. So if C is made negative, that is pivot is at O double dash. So what here trying to say here that this distance, if c, this distance is c. So if it is made negative, so it is in other direction. So uh, negative, so if the pivot is at o double dash, so what is the pivot here? So pivot is, so this is the pivot, and if this pivot is changed from here to here and from here to here, so in that condition, so the pivot when it is in upwardmost direction, so the c is made negative here. So c will be equal to negative. So that is uh, the force F will be equal to Rn, that is B plus mu C divided by A for counterclockwise, and B minus mu C divided by A for clockwise rotation here. So in case the pivot is provided at the same side of the applied force and the block and the block, so the equilibrium condition can be considered accordingly. So in this treatment, it is assumed that normal reaction and friction force act at the midpoint of the block. So what I'm saying is this normal reaction force, this is the normal reaction force, and the friction force. So this is the friction force, this normal friction force act at the midpoint of the block. So this is the block, and this is the supposed midpoint, where is the center. So this will act at the center of the block. So however, it is truly only for the small angles of the contact. When the angles of the contact are more than 40 degree, the normal pressure is less at the ends than at the center. In that case, mu has to be replaced by equivalent coefficient of friction, that is mu dash, and that can be given by mu dash can be given by when theta is greater than 40 degrees. So mu dash can be given as mu into 4 sine theta by 2 divided by theta plus sine theta. So this is mu dash. This is the coefficient of friction when theta is greater than 40 degree. So this is the formula for band brakes. So I hope you understood the band and shoe brake. I will just repeat it, that this is the pivot, this is the force that is applied, and the reaction force will act here. This is the friction force, that is mu Rn, and this is the normal reaction force. So if the drum is rotating clockwise, the friction force will be in this direction. If the drum is rotating counterclockwise, the friction force will be in this direction. The friction force can be in any direction based on the rotation of the drum here. So based on this, we have substituted various forces here and found the reaction force and the lever force which has to be applied here. Here A, B, C are the distances. So this is the A, this is the B, and this is the C here. So what else we saw today? That is the energy equations, that is kinetic energy, potential energy, kinetic energy in terms of rotation, and the energy absorbed is equal to braking torque into the angle theta. And also we have seen various factors of the capacity of brake, that is pressure, area, radius, coefficient of friction, and heat dissipation. And and classification of brake is mechanical, hydraulic, pneumatic, and electrical. And in this we have seen one brake, that is band brake today. So the main function of a brake is to absorb the energy and to reduce the velocity of a moving body. So that is the application of the brake. So it can be defined as a device used to absorb the energy possessed by a moving system or mechanism by the friction. So I hope you understood this, and we will see few more breaks in the next lecture. So thank you very much.